Hi, everybody. My name is Dotan, and I'm here to talk about GraphQL and why integrating GraphQL into modern application might save you a lot of time and effort and really a lot of time. So a bit about me. My name is Dotan, and I'm a freelance developer, and I am a part of a group called The Guild. We are 28 open source developers, and we are doing both projects and open source, most of them with GraphQL. So I'm a guild member, and I'm also a contributor to Apollo project, which is a client for GraphQL. I'll talk about this later. This talk is not about an actual implementations of GraphQL. I wanted to talk about GraphQL introduction and to talk about GraphQL spec, the specification itself. So let's begin. So as I already said, GraphQL is a specification, and it's a query language, which means that we can use GraphQL to query for data, and it's also schema-based, which means that we declare the schema, we declare our entities, actions, and everything else, and it's also strongly typed. So when we are declaring a type, GraphQL will validate and make sure that those types will be the actual type that we really want. Also, GraphQL is a specification. It means that you can implement it with any language, any platform, both on client and server side. It also works with your existing data, which means you can add it today to any application just over your data layer and use GraphQL directly instead of the old API. So let's start with a minute of history. GraphQL was developed by Facebook in 2012. It started as a solution for a problem. In 2012, Facebook mobile app was written in HTML5. It was a web app running in a native environment. They wrapped it to execute it in a mobile native app. And it was a problem because mobile application requires less data. They display less than the desktop application. They need less data. Usually, it's even formatted differently. So when Facebook used the existing REST API, they had a problem because they were fetching so much data they don't need. So Facebook came up with GraphQL, and it used mainly for internal APIs back in 2012, but they released it as open source in 2015, and ever since it has a really growing community. There are thousands of developers that already use this technology. And it's important to say that GraphQL is not a new technology because it exists for a few years, and it's already in use by many companies in production. This is just a partial list. There are really a lot more companies that use GraphQL in production. And taking a look at this list, you might think that there are here companies, enterprises, startups, small companies, and big companies, but those companies usually don't have common ground when dealing with development because the development process is different and they usually do things differently. But all of them chose GraphQL, so let's start and understand why. So when using REST API, most of the applications do it today. We're creating REST endpoint to expose data. Let's take this for example. It's a REST endpoint that exposes list of repositories, And it's just the name of the repositories. So if the client side needs more data, it needs to ask the server again, do another HTTP request to fetch more data. This is the example. So if I want the list of contributors for a specific repository, I will do another request, and so on for each repository. So probably most of you think now that, okay, I can just merge all of these data into a single request. And this is correct, because you can just add all of the data to the same response and return everything. But this is usually just overfetching, because we don't want all of this data. And when we need the actual data, we go to the backend developers and tell them, come on, please add more data to this endpoint. So backend developers will become frustrated. They will go, they sit down, they'll be mad, and they will add your data to this endpoint. And a week or two later, you will get your data in the same endpoint, and the client-side developers become frustrated because they didn't get the actual format of the data, and it's not in the JSON the server-side promised. So that's a problem. So GraphQL is here to solve this problem. With GraphQL, you can create a server-side that exposes single endpoint that manages all of your data. Think about GraphQL not as a server that exposes data, but as a server that exposes capabilities. And when these capabilities are available for the client, he can choose what does he need to render the UI or for its processing. So this is an example. We can ask for a specific field of, for example, a hero, and we're getting just what we need. So GraphQL also makes everyone happy. You probably ask why. And that's because everyone that takes part in the development of the application become part of the actual coding, because you can take your architect and your product manager and system designer, even your graphic designer, and they all sit together, they talk, and then agree on the schema. And the GraphQL schema, think about it just like a contract between the clients and the server. So this is an example for a schema that exposes query, and you can see we just declare it as types. As I said, it doesn't matter on which platform you're running it, it will work. It doesn't matter which language. You can do it in JavaScript, Node.js, Java, .NET, everything. So after agreeing on this contract, the client-side developers can just run and do the actual development, because they don't need to wait for the backend guys to connect the actual data. They can start working with mocks, and because the schema is a contract, it's promised to them that the data will become on the same format, on the same types, and everything will be exactly as promised. Another good thing, the schema is flexible, which means we can change it, modify it, and add new fields without breaking the old APIs, because if we add a new field for a specific client, he can use it, but we don't need to break the actual schema. You can also, another thing about GraphQL is that it splits your schema into small atomic pieces. Take this one, for example. Let's look at the type me. And we see that it has some fields. And those fields, each one of these fields has its own pure function. In JavaScript, it's just a function, same with .NET or anything else. And this atomic function is in charge of getting the actual value of the username. It does not do anything else. And this means that each part is atomic, and later we can get insights, get statistics, how long was it to fetch the username. We can also fetch it from another data source, which means that the GraphQL server can merge all of your data sources into one. You can take any database and any REST service or legacy service that you use. You can just take them all, combine them together, because each function, each pure function is in charge of providing a specific field, and this specific field is atomic and can come from any other data source. Okay, so let's break it down, and let's look GraphQL, split it into two pieces, the graph and the QL. Starting with the QL, GraphQL is a query language, as we said, and it has a cool feature. Just a moment, okay. So GraphQL, when developing with GraphQL, we usually start with the schema. After agreeing on the schema, we need to expose it from the server side. This is a cool example of schema. You can see on the right the server side schema, and on the left the client side. And the client side can ask the fields it needs, and the server side declared exactly the fields and the types, and we don't need to specify like the types or anything else in the client, just the name of the fields. So GraphQL is built with few types, few operation types. The basic one is query. Think about it as GET request in REST endpoint. The goal when using query is to fetch data from the server to the client. And when we're doing it, we can like add an extra metadata. For example, we can ask for something that is a date, and ask for a specific format, and for specific fields instead of getting everything from the server. Okay. The next operation is mutation. Mutation is our way to create or modify data in the server. The client needs to change data, so he mutates it and get a result from the server. So we can also provide the variables and anything else that we need for the actual mutation, and the response is the same. We specify the fields that we need, and this will be the response. Another operation in GraphQL is subscription. Subscription is our way to get real-time data from the server. Usually, it's a side effect of a mutation. If one of the clients mutates the data, for example, writes a new comment, we want to subscribe to it, and the other clients will get it immediately. At the moment, it's implemented with WebSocket, but in the future, there might be another implementation, like using push notifications or FCM or anything else that you use. Recently, I worked with the Apollo and the GraphQL team to create the WebSocket transport for the subscriptions. You should take a look at it. It's in GitHub, and it's already production ready and in use by many projects. Okay, the next one is Fragment. It's not an operation, but it's just a cool tool from GraphQL for reuse. For example, if we have a query and a subscription that both get comments, for example, all comments and new comments, we can, instead of specifying all of the list of the fields, we can just create a fragment and use it in both. Okay, so we got the QL in the GraphQL. The next is why it's a graph. So we'll dive into this, and let's see an example. This is a simple schema. For example, the user type, we use it in me operation, and it has few fields, ID, name, friends. Note that friends is an array of users. So we can use any type inside itself, and this way it just connects as a graph. This is how it looks. The me goes to user, and then the user fields. Okay, so this is how the schema looks, but this is an example for query. The client side asks for data, and the GraphQL server will execute this query using the schema we created, and it just go each one of our requested fields. Let's start with the query. This way, GraphQL knows to execute the root type of query. We ask for me, so me is the next field to run. And again, it's just a pure function. For example, me is the current active user. So we want, I don't know, to check his token and validate it, maybe use it with external authentication service or microservice that does that. We can just do it in this pure function. And then we return the actual user. And in order to get the fields that we need, starting with name, again, a GraphQL executor will run the name resolver to get the name and return it to the client. Next, our query looks for friends. And as we saw earlier, the friends is an array of user, which means we can just take friends and treat it just like any other user object, and the resolver of user will be executed again. And for name and for ID, and if you have more than one friend, I hope so, then this resolver will be executed again. So this is how the GraphQL behaves as a graph of entities and relations between our data. Okay, so yeah, the idea is the last one. The next thing I would like to talk about is UI frameworks and how to integrate them with GraphQL. Usually, when we think of UI frameworks or UI code, we don't always combine the data into our component. We usually add UI logic that manages the UI state, but the data come from the outside. And most of the applications today are built as a tree of component with a root component. Usually we have a router or something like that that manages the app state and the main view. And each view is split into smaller pieces. And usually when we do it, each component is in charge of the UI only. And sometimes, for example, when we work with the Angular 1 or 2, it doesn't matter, we usually implement a service that's in charge of doing the HTTP request and manage the data, and we just use it as an attribute or props in React to connect the data into the component, which is good. It's great, but we also want the component to get only what it needs, because when we do the actual request, we'll get a lot of data, but we want to minimize this data only to the data that the client needs. And front-end developers really struggle with this stuff, because when connecting components to data, usually we need caching, and we need to create transformations on the object, and it causes the client-side developers to focus on the non-important stuff. Instead of develop the actual components, they try to get the data correctly. So to understand why GraphQL is great also for UI and not just a data solution, there's a small application here, a social application, and we can see that the application is split into few pieces. The first one is the navigation bar on top, and we have a list of users, for example, people you may know, or something like that, and action buttons for follow, chat, or anything else the app needs to do. So let's take, for example, this small piece. This small piece says, hello, Dotan, and actually, the only thing that this component needs is my first name. It doesn't need all of the user object that the server exposes. So we can create a query, GraphQL query, that returns, that asks the server only for the first name of the user, which is me. Let's see another example, the people you may know list. You can see here that we have the first name, last name, and the avatar, and the description, and anything else. We also need to know the state of the following, for example, to know, so the UI developers can choose to show follow or unfollow in the button text. So we also ask this from the server, and we ask a specific data about the user. And probably the user has a lot of fields, because user object usually contain more than just this list, but these are the only fields that we need to display this list. So we don't need to send over the network more data. Next one is this follow button. This follow button, we use it to do an actual action. It connects to what we said earlier, to the mutation. And this is, for example, a mutation of follow. It has a variable that accepts the user ID, and in response, we want to get the new state of is following so we can update the actual UI. But we can also expose more stuff. Think about it. Think about, for example, privacy. If I'm not following this specific user, I probably can't see all of his data or any other information. But after following it, I want to get more data that's now available for this specific line. So I can add it in the mutation, and the mutation not only returns the state, the new state, it can also return more and new data. Okay, so as we said, GraphQL exposes your schema, but it's not just it. GraphQL can manage state in the client side. It can also do caching. It can create responsive application and reactive application with subscriptions. And you can actually run it on anything, any backend. There are currently implementations for Node.js and .NET. You can use any one of them. You can use it with any language and any UI platform. Another thing that I want to say is about Apollo project. Apollo is an abstraction over GraphQL. It's just another layer, and it helps you to connect GraphQL queries and mutation and data to the actual component and UI. And you can also use Apollo in the server side to create your GraphQL server easily. Just a few minutes to create a GraphQL server. You just need to decide on your schema. And I recommend you to start with the Apollo or GraphQL, doesn't matter, but Apollo really does great things to the UI when working with it. Another feature is the optimistic UI. Most of the applications today wants to give a feedback immediately to the client when he mutates the data. So you can also use this feature. So for those of you who wants to start with GraphQL, you can just go to graphql.org. It's the official website of GraphQL. It has the full specification of GraphQL, and it also has a list of current implementations for all platforms. You can also go to the GitHub of GraphQL, great resource for information. And the Apollo project I mentioned also have a website with tutorials and applications that use GraphQL, and you can just use it as reference for implementation. Another thing that I wanted to say is about serverless. I guess most of you was yesterday in the talk about serverless, and with serverless you can just take pieces of your logic and your business logic and execute it somewhere else, but the main goal is to take those small pieces and execute each one individually. So think about GraphQL as a similar solution. You can take your schema, and each field is atomic. And it just do the actual simple logic that you need to return the specific value. And actually, there's also an implementation for executing GraphQL over AWS Lambda, so you can just use it if you want. That's it for now. I hope you liked it. And if you want to get into GraphQL, you can always contact me. I'm available on GitHub, or you can find me somewhere here. That's it. Thank you for being here.